In this lesson, you will learn of the properties required of aircraft hydraulic fluids and of the necessity to have well-designed pipelines for carrying the fluid around the system. Plus, we will look at the design of the various seals used in a system to stop the fluid escaping. There are a number of properties that we would ideally like hydraulic fluid to have. Firstly, it is essential that hydraulic fluid is relatively incompressible in its normal pressure range. That is, up to 276 bar or 4000 psi. This will ensure instantaneous operation of the services. In fact, almost all liquids have this property. In the diagram, we show the effect of applying pressure to a container of liquid. When a pressure of 346 bar or 5000 psi, well above normal system operating pressure, is applied, the liquid is compressed by only 1% of its original volume, and 99% remains. Hydraulic fluid must have good lubricating properties for both metal and rubber, as it will be used as the lubricant for all moving parts throughout the system. It should have a viscosity low enough to keep friction to a minimum, but high enough to help prevent leaks. Viscosity is a fluid's resistance to flow. The higher the viscosity, the greater the resistance. The fluid needs to have a high boiling point to help prevent cavitation, and a very low freezing point, as the reservoir may well be outside of the heated fuselage. The minimum required range is plus 80 degrees centigrade to minus 70 degrees centigrade. Cavitation will be explained in a later lesson. Hydraulic fluid should be non-flammable, or have a flash point above 100 degrees centigrade. It should be chemically inert and be non-corrosive. It needs to be resistant to evaporation and have freedom from sludging and foaming. Finally, it should have good storage properties, as well as being reasonably priced and readily available. No current hydraulic fluid has all of these properties. There are two types in common use, both of which are toxic and will damage skin, paintwork, sealing compounds, perspex and such like. Both types of fluid are an irritant. Eyes should be protected from them, and prolonged contact with skin can cause damage. Any contaminated skin should be washed with soap and water immediately. The two types of fluid you are likely to meet are Defstan 91-48 and Skydrol. Defstan 91-48 is a super clean mineral hydraulic fluid. Recommended for all hydraulic systems operating under high pressures and low or very low temperatures, from minus 54 degrees Celsius to plus 90 degrees Celsius. It is equivalent to H515 NATO, OM15 Joint Service, and MIL-H-5606F in the United States. It is normally coloured red and is used in hydraulic systems with synthetic neoprene rubber seals. Skydrol is a phosphate ester-based synthetic hydraulic fluid, which is purple in colour. It is used in hydraulic systems containing synthetic butyl rubber seals. Prolonged exposure will damage skin, and eyes must be protected from it. All measures should be taken to avoid skin contact. In the event of a leak, it may spray out as a fine mist, and eye protection must be worn when investigating leaks. If any hydraulic fluid does come into contact with eyes, then they should be rinsed thoroughly with clean water. A medical assistant should be sought. It has a very high flash point of 170 degrees centigrade and is less prone to cavitation than mineral oil type fluid because of its high boiling point. Skydrol is the most dangerous to personnel, but most modern airliners use Skydrol in their hydraulic systems. Both of these fluids are flammable if subject to sufficiently high temperatures and a source of ignition. However, because of its very high flash point, Skydrol is much less so. It is of major importance that only the specified hydraulic fluid, or its approved alternative, is used in a hydraulic system. If the incorrect fluid is added to a system, breakdown of the seals is likely, causing fluid leakage, both internally, within components, and externally, from the actuators. Failure of the seals in the pump could well lead to overheating. Filters may become blocked with debris, and parts may be damaged by corrosion. The colouring of the fluid assists in its identification, and also assists in finding hydraulic leaks. However, it must never be used in isolation to identify a type of fluid. The fluid may not retain its original colour when it has been in use for some time. The specification can only be confirmed by consulting the aircraft manual and by only using fluid from sealed containers or the appropriate replenishment rig. The efficiency of a hydraulic system is governed by the resistance to motion encountered by the fluid. Force is expended in overcoming static resistance, which is friction in cylinders caused by moving parts, piston rods rubbing against bearings and seals, and by fluid rubbing against the pipe walls. Large bore pipes and frictionless pistons would allow nearly 100% of the force to be utilised, but would incur large weight and cost penalties. Friction between pistons and cylinders, and piston rods and bearings, cannot be completely eliminated. It can only be lessened by good design and workmanship. The friction between the walls of the pipes and the fluid depends upon the velocity of the fluid in the pipes, the length, bore, and the internal finish of the pipes, and the number of bends. Good systems are designed with pipe runs being as short, wide, and straight as is practicable. Seals perform a very important function in a hydraulic system, their primary purpose being to prevent leakage of fluid. Static seals, gaskets, and packing are used in many locations, and these prevent fluid leaks by being squeezed between two non-moving surfaces. Dynamic seals, fitted between sliding surfaces, may be of many different shapes, depending on their use and on the fluid pressures involved. U and V-ring seals are effective in one direction only, but O-rings and square section seals are often used where pressure is applied in either direction. Where high pressures are used, an O-ring is normally fitted with a stiff backing ring, which retains the shape of the seal and prevents it from being squeezed between the two moving surfaces. Dynamic seals require lubrication to remain effective, and wetting of the bearing surface, or a slight seepage from the seals, is normally acceptable. Seals are made in a variety of materials, depending on the type of fluid with which they are to be used. If a seal of an incorrect material is used in a system, the sealing quality will be seriously degraded, and this may lead to failure of the component. Similarly, if the incorrect hydraulic fluid is used, it will almost certainly damage the seals. Seals are easily damaged by grit, and a wiper ring is often installed on actuators to prevent any grit that may be deposited on the piston rod from contaminating the seals. That concludes the lesson on hydraulic fluids. You should now know all the desired properties of a hydraulic fluid. You should also know the properties of and the differences between the two commonly used fluid types, including the differences in colour and the types of seals that each can be used with.